Jag kommer att göra så här, jag kommer att byta språk. Jag vet vi har många studenter i publiken. This is going to be a 20-minute talk, not only about the importance of AI. I think we're all exposed to, how AI is kind of impacting our lives. What I would like to do is I would like to tell you more about what AI is, and maybe also why AI is the way it is. So let's start with the basis of what builds AI systems, and that really is the notion of algorithms. And the reason why I'm spending so much time to tell you about these things is because I want to demystify AI. My impression, if you read the newspaper, is that there's a lot of excitement around the technology, but there's also a lot of fear and concern. And I believe knowledge is the way to give us a little bit of safety and security about what this technology really is. And it's built on the notion of an algorithm. And what is an algorithm? Well, if you've ever baked a cake or made any kind of meal, you've usually followed a recipe, at least if your baking skills are as good as mine. You've relied on recipes. And recipes are instructions, and algorithms are instructions, often instructions described in math, but algorithms can also be instructions for computers. And today, when you make a computer program without AI, like, for example, your web browser, it consists of about 1.5 to 3 million lines of code. And all of that code is written by a human. And what we want to do with AI systems is we want to be able to generate code, which basically is an algorithm that can be done automatically. So a human doesn't have to say exactly what should be done. Does anybody know who this is? Turing. And Turing had this breakthrough that he reasoned that, wait a second, if you can give instructions to computers, could you give the right instructions to a computer so that it actually seemed intelligent? And he started to think about what kind of tests you could make to make sure that this computer is intelligent. And Turing said, well, if you could fool a human that the computer is intelligent, then the computer is intelligent. Now, some people use this reasoning about AI. They think that if AI looks like us, acts like us, and behaves like us, then it must be an AI. But most researchers, like myself, we think that we can get something better out of AI. We think that it's not important that AI looks like us and acts like us and even maybe has processes that we have, but rather, what if AI could show an intelligence that's different than ours, but that helps us? A good analogy of that is what happens in aviation. If we wanted to do a Turing test for aviation, we would have to make machines that fly like birds, that act like birds, and that fool all the birds that it's also a bird. Now, we can do that, and actually the very first flying machines, if you've seen those videos, we based it on birds. But actually, by understanding the fundamental principles behind flight, we were able to build machines that could fly hundreds of people in the same machine across the entire world in a way a bird never could do. And of course, there are advantages and disadvantages, but the point is that we were able to build a machine to help humanity. And that's what AI researchers are trying to do. Now, AI is an umbrella term, and this is also something that I want you to be aware of, because not all AI is the same. It works in very, very different ways, depending on what kind of AI you're talking about. And so when you read the newspaper, or when somebody comes to you and says, AI is the thing, if you really want to question them, ask them, what type of AI do you mean? Are we talking about machines that learn? Are we talking about machines that reason? Machines that communicate? Are we talking about robots? What AI are you talking about? Don't let them use the umbrella term without being sure that they know what they're talking about. AI is also not new. It's been going through a big development since, I would say, the 50s. And its development has had a number of what we call summers, which have been wonderful periods and things have gone well, and winters, which are very much like the Swedish winter, where things are a bit gloomy and expectations are not met. And right now, we are in an AI spring or summer. We're going through another hype cycle. Another thing that's important to remember is AI is general purpose. So everyone who has an industry, company, organization is probably going to need AI at some point. It is not a technology only for the technical. So what does AI look like? Well, if we go back to one of the hypes that happened, and this one happened in the late 90s. This is basically, let's say, a development where we showed that AI could actually beat a human in chess, Kasparov in this case. If you want to see something funny, we could actually develop very fancy AI systems that could play chess. We could not have a robot or a system that can move the chess piece. You notice there's this guy here on the screen. His only job was to read what was on the computer and move the chess piece. Not too exciting, but that shows you the difficulties of automation. Now, this kind of AI is very simple because what it does is it simply models all possible options at the same time. And that makes AI very powerful because you can take a lot of information, you model every single possibility. I'm not going to go through what I'm showing you here, but if you know all possibilities and you know the result of every possibility, you can choose the best option that will lead you to a win. Funny, we now have AI systems that play chess better than any human. But we don't necessarily see our humanity as being threatened by them. Now, we have different types of AI systems today. These are what we call neural networks, and basically they're based on machines that are able to learn. Our brain has a lot of neurons in it, and neurons fire based on the information you receive. With these kinds of AI, you feed in information. So right now I'm feeding in the number 7. A whole bunch of neurons are firing, and we don't have to maybe focus on how that works. But somehow there's a pattern here that fires so that the system can learn after seeing enough examples of the number 7 that this particular shape leads to a 7. And this kind of machine learning is really, really useful. And in fact, the reason why it's useful is because we can not only, for example, recognize faces and recognize images. That's not the magic. The magic actually happens inside these neural networks. Because we can feed a lot of data to an AI system, and what we're able to do is we're able to open up the AI system and we're able to ask it, how did you learn this task? So what I'm showing you on the screen is basically how an AI learned to recognize a face. First, it starts to see contours, dark edges, light edges. Then it starts to see that there are relationships in this second layer here. It sees that eyebrows are above eyes, noses are above mouths. And then it starts to see a face. And that's the insight. The insight is by looking at how an AI solves it so that we can understand better how to tackle problems. And we've used this now in many, many fields. For example, in being able to recognize cancerous tissue from non-cancerous tissue. From, let's see here, being able to very quickly also recognize cancerous tissue from non-cancerous tissue, and even being able to do prediction. I have a little bit of difficulty with this. It's not going forward. I wonder if you can help me here with my slide. The clicker. There we go. I don't know if I have to point to anything in particular, but we see it in automatic driving. We see it in examples where we can actually feed an image into an AI, and an AI is able to give you a description. And perhaps also something that I think is particularly fun is that we can even use AIs to learn how to do things by trial and error. So this is an example of an AI that is basically learning how to walk by seeing all of the different possibilities. Remember I told you about chess. We look at all the different possibilities until we find one that works. So if you look at this walking individual, eventually this is the solution that works. Now, you might remember what happened on this date. Anyone want to say what it is? Say it out loud. ChatGPT. Yeah. ChatGPT works a little bit differently than the AI I showed you, because instead of being able to tell, okay, in this image I have a cat, in this image I have a dog, what the AI does is it describes the shape of your data, and then it creates a new instance that follows that shape. That's kind of the easiest way to explain what we call generative AI. And that generative AI can then be used to generate new data and something that you haven't seen before. And we see it with ChatGPT, and I'm sure almost everyone in the room has used ChatGPT. So this ability, what I'm showing you here, is how do we generate an example of how the face would move, even though this particular face would actually never move. Now, I've given you a little bit of an example of how AI works, but I want to talk to you about the challenges. So, is AI perfect? Absolutely not. It has a lot of power, but it makes also mistakes. ChatGPT, as we know, makes mistakes. The problem is, it's not the mistakes. The problem is that we don't really understand why it makes mistakes where it does. Let me show you. So here we have an AI that looks at this picture and says, haha, a panda. And I'm about 60% sure. We put in a little bit of noise into our system, and now it says, oh, it's a gibbon. And a gibbon is a type of monkey, and it's 100% sure, or almost 100% sure. And the problem is we don't understand what this is doing to confuse the system. We can also see this happen in autonomous driving. And if you want to fool your autonomous car, I don't recommend you do it. You can actually just put a little bit of tape onto the stop signs, and your car won't recognize that it's a stop sign. It might actually think it's a speed limit sign. But there are other challenges. Those are the ones about the AI. But we're also in, let's say, in business, there are a lot of challenges. The biggest challenge when I'm talking to companies is that they're interested in AI, they see the need for AI to stay competitive, but they have a hard time finding the business case for which AI will give them the most value. And then they come and talk to a computer scientist and they say, how can you help me? And often the computer scientist maybe isn't the right person to talk to. And in fact, I'm very happy that the students recognize the need for competence, because the competence that we need for the future is not only people who can build the algorithms, but people who understand the algorithms well enough to do something very impactful and very important with them. And that's a competence that we have to learn how to create together. The other challenge is that if you would imagine that this black box is your AI, when you start to put that into a system, you have to have a lot of parts in that system. So that black box is only a small part. You have to have parts in that system that deal with data. You have to have parts that deal with computational infrastructure, parts that deal with visualization, parts that put humans into the loop. So it's not easy to integrate AI, but it is in fact becoming more and more necessary. And when it comes to the future, I think that there's something that we should remember, and that is that our aim is not to create AIs that completely replace humans. But as I said in the beginning with the example of the airplane, our aim is to create something that can complement us. And if you're wondering about chess, now there is a chess competition where an AI, together with a human, are a team, and they play against another AI and human. Often people say, will AI take all of our jobs? And I tend to say, it will transform the job market, but if you want to be worried, be more worried about the human who knows AI, because that's a bigger threat to the job than an AI itself. And we're talking about the area of mining, and I think that it's important to kind of lift where we see the potential areas where AI and mining can marry and be utilized. And I think it's really everything from using remote sensing to be able to automatically process satellite information to understand what possibilities exist for exploration, from doing prediction and predictive analysis. We are working with a company called OrExplore and helping them using AI. We actually have an industrial PhD student who's working on a number of topics there. But not least, also going towards more autonomy in areas that are very, as we say, dull, dirty, and dangerous, that we can have autonomous solutions. And to make smart machines, those machines also need more AI. Just a few words that I want to say about the Swedish ecosystem, because there is one and there are a lot of investments happening in AI research and development. The majority of the investments are being spearheaded by the Wallenberg Foundations, where there are major investments in, for example, competence development, research. This program here called WASP is a 6.2 billion Swedish initiative that goes until 2031. But then you also have other initiatives that are really trying to see how one can facilitate the implementation of AI. And perhaps my favorite are those initiatives that are looking at competence development, which means how do we create new programs at universities, but also how do we do upskilling and reskilling in the area of AI. And with that, I'll leave you with this picture. Remember, it's a broad area, and thank you very much.